I'm going to give a brief self-introduction. I'm based in San Francisco with RBC, and I'm an investment analyst. I cover the telecom carriers, telecom infrastructure, internet infrastructure, data centers, hosting, cloud computing. And I'm pleased to introduce Bill Rue from GE Software, and maybe provide a little bit of context for the audience in terms of your activities, GE's role in Internet of Things.
Yeah, so about 5 years ago, GE realized that, and they could see the customers were starting to change how they used our products. So GE makes locomotives, CT scanners, gas turbines, wind turbines, a lot of oil and gas equipment. And so when you look across this, we love rotating machinery. Anything that rotates, that's what we love to build. But the reality is that when people look at operating these machines over 20, 30 years, we were finding that they were starting to add a lot more sensors, they were demanding a lot more sensors, and they were starting to use data in new and innovative ways to change how they use those assets. They were trying to get more out of it. And we realized that a lot of the people we were seeing work with those customers were different than our traditional competitors. We're seeing what we'd see new startups. And I think as a company we realized if we didn't start to get into the game of software and analytic products surrounding how we connect machines, use data, deliver analytics so they can get more out of an asset, somebody else would. And in the end, that's going to be the most valuable kind of commodity in the world today, is how can you get more out of these kind of assets. They're big, and we intend to play in that space, but we also see it as a huge market.
So on that point, so the opportunity that you see concrete, how would you kind of size it, dollars and cents wise, both for GE and maybe for some of your partners?
Yeah, we did a study, and it's on the GE website, and if you just go to gesoftware.com, you can get this paper. We call this the industrial internet, and the reason we did is we realized that most of the money is being made on the consumer internet. In fact, if you look, it's really all about the consumer today. The industrial side, I think we realized, however, is a much bigger opportunity. So Bank of America, did a study. They showed it in the industrial sectors we serve. There's $32 trillion a year spent, and I think whether it's 25 trillion or 50 trillion, it's still the biggest number and biggest economic activity globally. We did a bottoms-up analysis, and we then began to say, look, what if you can get just 1 mile per hour more per average out of a locomotive? What if you got 1% greater fuel efficiency on a gas turbine? So gas turbine, 1% fuel efficiency on just our gas turbine fleet globally is $6 billion of opportunity. 1 mile per hour faster on a locomotive average per day is worth $200 million profit to a rail. So you start to look, and we found just in bottoms up across the top 10 industries in the world, there's $1 trillion with a very small efficiency gain in big machines. And those gains are not going to come because of the physics, because we're starting to see the physics is slowing down into what you can achieve. But the real efficiency is in the operations of it. And we've seen some amazing ability to build software that provides these kind of changes in the world.
So you need a network to make this happen, and how would you characterize some of the challenges? Is there an opportunity for carriers? Yeah. How do you kind of view that side of the equation?
Well, I believe that the carriers have probably the best opportunity because they have this important piece of real estate, which is the connectivity. And just having sat in a lot of these sessions, I think that the idea of IoT is, I don't think that oftentimes they realize how much machine traffic is already running across the network, right? But the fact is, that there's a bigger opportunity above that. Well, the real game is going to be who is able to provide a series of services on top of that. If you want to think of it, the killer app that enables people to do a bunch of things. One is they have to be able to put intelligence into their machines. And because you're going to have to do more at the edge. what we've discovered is that a lot of the technology is being developed, or how do you get pages faster to your mobile devices, things like that. You're not serving up pages. And so in the end, you've got to rethink the edge computing environment that's out there. And everybody who builds machines is looking for solutions. The second thing is that you start to look about how do you collect data and how do you do analytics on those at a very fast rate. And so when we look at it, it's not just the analytics, it's actually one thing. It's this idea of zero unplanned downtime. That's the killer app. So if you can bundle this and be able to allow customers to give zero unplanned downtime, we see this as this $1 trillion to $2 trillion a year of inefficiency in the system that's immediately available. And so when you think of IoT, nobody in a business like a rail says, I want to connect my locomotive. Could you please connect everything I have? And because there's no value in it. But if you come in and say, look, I can show you how to get to zero unplanned downtime, now they want to have a conversation with you. And so if you think about the last 2 tries in the industrial sector for IoT that failed, RFID was the first, because it was, we can connect all your stuff. Well, that didn't work. Nobody cared. Then it was the smart grid. Remember the smart grid was the $1 trillion opportunity? And all those companies now are sort of not turned into $1 trillion opportunities. It's because everybody was just saying, I'll connect you. I'll connect your machines. And the buyer's not the CIO. The buyer is the operations guy. And so the opportunity is, as a service provider, can you go sell to a non-traditional person? Can you move from selling to the CIO, which you're still going to sell to? Can you sell to the head of operations? Can you tell them, I can deliver zero unplanned downtime by connecting all your machines and giving you this killer app? And then suddenly you're into a conversation. But that really means you've got to move from the IT environment to the OT environment, operations technology. And I'd say this is where that service providers are going to, if they want to play here, are going to have to rethink their ecosystems. It's not going to be IT vendors that are your best partners. It's going to be guys like us who can actually help deliver on that promise.
So talk a little bit about the progress you've made, and different carriers have extremely entrenched cultures. Is it going to take months, years, quarters? How do you kind of view the cultural challenges, I would say, and are they as significant as the, or maybe more so than the technical challenges?
Yeah, I joined GE a little under 4 years ago, and I was fortunate that at our chairman and CEO Jeff Immelt, and he goes out and says now, if today you woke up an industrial company, tomorrow you're going to wake up a software and analytics company. And he really believes this. It's not that we're going to stop selling locomotives because we're going to make all our money there, but he's saying if you don't have as a core competency software and analytics as an industrial company, you can't play in this game. And the last discussion on cameras, if your whole world is analog cameras, you can invent the digital camera technology, but you don't know how to absorb it into your business. So he's saying, we're going to absorb this in our business. So we've made an investment of about $1.5 billion to get ourselves organized. And we've built out applications around, say, our wind turbine. We've built an application that takes weather, sensor, wind data. It takes a lot of historical data about, and looks at what kind of behavior is the best for an individual wind turbine given a situation. And that software generates 5%, 4 to 5%, we say 4%, but we're almost always seeing 5% more electricity. And when you take that 5% is 20% profitability to them. So we are building these applications that are like this against our product line. And as a result, we have 40 of those out there. We'll generate well north of $1 billion of net new revenue on those this year, or in 2014. And so for us, we've learned about the killer apps, and then we've figured out the kind of industrial fabric you need to collect industrial data, to secure industrial data, to do the edge computing, to do the analytics, so for us, it's the idea of that kind of an industrial framework. I think as you look at the opportunity, what service providers have to think about is How do you, take their data center, their cloud, their the bandwidth, the network, and monetize that with this kind of capability to go deliver this? And we signed a deal with SoftBank, for example, in Japan to do exactly this. So we're now going in the market talking to industrial companies and saying, look, we can help you take all your equipment, put KPIs on them, and optimize your equipment out in the field. So everybody who builds a piece of equipment is seeing new opportunity for themselves, new services they can offer using this kind of capability, plus they deliver a better experience to their customer. So I think this kind of thinking has to go into it, but you got to remember it's different than the consumer internet, and it really does require a different way of thinking to go after this market.
So I do want to open it up for questions. We have about 8 or 9 minutes left. If there are any, please make yourself visible. You did mention cloud briefly, so service providers, I was kind of thinking more carriers, but in terms of more the cloud-centric providers, where do they play in this equation?
Yeah. Well, I think that that's going to be an interesting discussion. I think that this gets down to who's going to win the battle, right? Because there will be, given the size of this market, we already start to see it heating up. So you can look at a company like Google, for example, and they got great analytics skills. They have a cloud search environment that can't be beat. They don't need network providers, et cetera. They could decide to go into the space. The thing that they missed is domain knowledge. So they would need to partner with people in these domains because they have tried healthcare and it hasn't worked out for them, right? So domain knowledge is important. So they have an opportunity. I think that, and then you look at what Elon Musk has done in automotive and space. He's already shown that you can get into this and disrupt the market. So I think that cloud providers can get into this space with the right partnerships or gathering the right domain knowledge and could move faster. The thing is, I think in 2 to 3 years, it'll start to become too late to form a strategy and move forward. But it is unclear to us who our best partners should be, who we should work with, who's got, because you are having to deal with a much higher level service. But the fact is this will be delivered as a cloud with the one thing that changes here and why the cloud guys may or may not play well is there's a lot more at the edge. You cannot ignore the edge. You can't bring everything back to the cloud. It's a different environment. And that's where I think the winners and losers are actually going to appear, is who gets it on the edge, who can make the edge and the cloud hum together.
Yeah, that's an interesting convergence that I think has been highlighted in some of the other sessions. Audience questions? In the back.
Hi, my name is Mark Adams. I was just wondering, I hear comments of 10 billion devices talking to each other. The amount of traffic here is huge. How do you separate the wheat from the chaff? That I could see systems choking on the amount of information that's just log files that are just rolling in. How do you manage that?
Yeah, that's what I get to the edge devices. So I'll give you a couple of examples. One is, our latest engines, jet aircraft engines, can generate 1 terabyte per flight. And so you're not gonna send 1 terabyte during a flight, and so you're gonna do more real-time processing near there. So a lot of the real-time embedded systems, which is the edge computing environment, are now becoming more programmable, where you can add in analytics inside an aircraft or on a locomotive, and that's going to be the future. You're going to collect a lot of data, and then you're going to do the analysis. The second thing is you've got to find the right time to move the data. So for us, the right time is you pull up, and while you're refueling and they connect, you're downloading the data. The second thing is, though, you don't always want to download everything, and this is the tricky part, is what do you want to keep, and how long do you want to keep it? So you could download the whole terabyte, but you then probably don't want to keep a whole terabyte. On the other hand, what we find is, as we go along, we keep finding the more data you have, the more interesting questions you can ask. So we have suddenly discovered, if I collect everything, and I have 2 years plus of data, we think we can actually diagnose any product or part that's going to break 100 flights plus before it breaks, because the signatures are actually in the data. So now you really have to decide, how much to keep and what's the cost and so on. So I think we're early on trying to figure this out. Most people are still throwing away a lot of data. But as we see the idea of prognostics and preventative maintenance as being a killer app, if I could tell you to fix it in a scheduled downtime at an airline, you can get rid of the 41% of mechanical delays, which is bottom line to the airlines, nearly $1 billion a year. So these kind of things, you're going to trade off that. Now, the fact is, though, however, it's going to come down to that they're going to look at a multitude of ways to transfer data. But I'll say this, they already are doing this. We are transmitting a terabyte when you land into a system. It's just not necessarily, the question is, what's the network? But the network providers don't know what it is. All they know is some data is moving around. They don't know, is it a video and so on. So there's a lot more going on than they think. Everybody's trying to figure out how to move more to the edge, but they're realizing collecting everything and managing all of this data could get to the point where you can do real prognostic maintenance that it sort of sounds like science fiction, where you are saying, look, I know it's going to break at flight 97. I'm going to fix it, 20 flights ahead of time. And now you've just really taken a lot of costs out of the system. So, I think that these are some of the driving factors, but we believe that people are going to collect more and more because of prognostic maintenance that AI techniques are going to drive. Without the AI techniques, they're going to collect zero. They're going to collect zero.
Joe.
Yeah, Bill, you talked a lot about kind of the architectural and economic philosophy. Could you also talk about how GE is shifting its focus to business outcomes and the differential value proposition?
Yeah, so this gets back to the killer app. What we learned is the technology is of no interest to the operations guys. You go and talk to the CIO, they get real interested. Yeah, I want to connect everything. I know we're going to go there. This is the strategic direction. And they know they're going to be left holding the bag to do the technical work. The problem is that that without that killer app, it's just the technology that no one is willing to put the money into. So the ops guys say, if you can show me either better generation on, more throughput on my equipment, or you can show me savings to that equipment. Now you got my attention because the numbers are so large. So outcome, everything is about outcome. And we, when we go in and talk, and I'll say that, our executive leadership will say, they don't go talk about the industrial internet, they don't go talk about connectivity or any of that. They go talk about zero unplanned downtime. And that's what people care about. That's the killer app. So for us, we found that it's all about outcomes, it's all about zero unplanned downtime. The other one is I can show you how you can generate more, optimize that piece of equipment. But if you look at it, anybody who's in the power generation business, you know how much electricity gets lost through the system due to inefficiency. We all know the healthcare system is ripe with inefficiency. We all can look at anything like, rail. I'll give you one rail example about how complexity has changed. So we have something called Movement Planner, and it advises how to optimize rail traffic. And last year in the US, with the extraordinarily bad weather, the storms were slowing down the system. And what we found is that we were recommending that the most high priority trains actually get parked, and the lowest priorities get moved during these weather. And those parts of the system that used that found that they cleared up in 24 to 48 hours. Those whose people ignored the advice and did it the way they thought, which is move the high priority stuff through, they were 2 to 3 to 4 weeks into it, and still the system was fully clogged. And the rail had to say finally, we want you to use that advice. And when they did, it cleared it up in 2 to 3 days. So the complexity of the system has got to the point where people make individual decisions that they just don't understand enough of everything. And the big data coming in is going to tell you that, but you have to see those insights. So if you can deliver an outcome where you can say, I can clear up this kind of congestion in a few days, that's worth a lot to them. And I think that's the killer app. If you deliver that killer app, you're going to pull through. They're going to be willing to connect everything, collect all the data, pay for the bandwidth, because it's a small amount of money compared to the overall economic advantage of getting rid of the congestion in 2 to 3 days in particularly nasty weather conditions. And I think that's outcome-based solutions are going to be the killer app here. And those who get it right will win, and those who try to sell the technology into the CIO will find that they're not seeing the kind of economic gains that are possible here.
So we're in 1 minute stoppage time. I'll just maybe wrap up with one. You gave some transportation examples, renewable energies, oil and gas, and some of the partners that you are working with in that sector.
Yeah, again, in oil and gas, I go back to the edge computing. We've worked with Cisco, for example, to take a hardened router that would sit on an offshore oil platform and taken our Predix platform technology, married them. So now I think the idea, again, of edge computing in the network, we've discovered the network is the best piece of real estate to put this. And when you start to think about your network and you start putting services at the edge, it becomes a very sticky situation, both for us, because our equipment is better. We provide just, an environment that delivers those outcomes. But at the same time, those people we're working with that can think about how to get higher level services in the network, it becomes very sticky because now your network is in fact an application. And as you know, applications are harder to replace, especially when the ops guy goes, but I'm delivering this, I make this much money, don't screw around with my operational environment. So I think the idea of the network, and that's a great example where we're working on the edge and it's in the network. And I think the network is the computer as we move into this kind of industrial IoT space.
So if there's anything beyond your control, and we're here a year from now, and we've seen some wild successes, what are the challenges that you will have observed either on the network side or on the technology side, or is it more a matter of culture and adoption?
It's all a matter of the industrials are particularly, I'd say, skeptical of technology, IT technology. And so they look at this and say, you're pushing IT solutions into my world. They're traditionally used to buying proprietary, let's say, stovepipe systems that the IT guys are often kept separate from. So now what we're saying is IT and OT have to come together. This is going to drive a cultural shift. And so those organizations that figure out how to talk to the CIO and the head of ops, those who figure this IT OT integration, that's where this is going to go towards. And I think that's the hardest thing, is it's a big shift. The OT guys are going to drive this. The IT guys are the ones who are going to bring the technology in. And that's where this has to come together. So if you think about, as a service provider, if you're going to play in this space, you got to think differently. You've got to have a strategy. You've got to have a new ecosystem, because it isn't IT. It's OT. But you have a great piece of real estate. You own something that nobody else does. And if you can figure this out, I think this is when IoT becomes a much bigger opportunity than selling even bandwidth and mobile phones and enabling cloud. It's going to provide the next generation of big leaps and bounds in revenues.
So there's spectrum auctions that are going to end any day now, and I think that'll help alleviate some of the congestion points. Yeah. So we are, okay, real quick question here. And
in a given organization, let's say there are 10 different OTs, will they end up with the 10 different IT as well? Will the IT be decentralized, or will it remain centralized?
No, I think this is the point that This is where it's the internet plays in, and I just simply say this. The future is going to be the world of IT and what we've learned about networking, et cetera, is going to replace these OT systems. And whoever figures this out and how to drive that in the right way is going to win. But remember, the OT guys are skeptical because that works. So the fact is we're going to get there where there are not 10 OTs. But it's going to take, it takes a little more work because there's two cultures coming together, and that's the hard part. So I just leave you with that, but that's what's going to happen. So
We are out of time. Thanks very much.
thanks, Jonathan. I appreciate it.